How are you guys doing? Today we'll be talking about the factor market. So let's jump right on in. So this is the circular flow model. On the top is the factor market, and on the bottom is the product market. In the product market, the individuals provide the money to the businesses, and in return, businesses provide goods and services. However, in the factor market, the businesses are the ones that are providing money to the individuals, which in most cases is a wage, and individuals provide their labor or their land to the businesses. In the factor market, the individuals are in supply and the businesses are in demand. However, in the product market, the businesses are the ones that are in supply and the individuals are the ones that have the demand. Those are the main differences between the two.
Alright, so here we're going to be talking about perfect competition. Alright, so the majority of the factor market operates within the perfectly competitive market. And there are two graphs here, the industry or the market and the firm. In a perfect competition market, the firm is a wage taker, and that means it derives the wage from the industry where supply and demand meet, which is the equilibrium point, and that becomes the wage. Profit maximization point, which is the same thing, is where MRC equals MRP. Demand is a downward sloping line because of diminishing marginal productivity of labor, which is basically mo labor, mo problems. A supply of the firm is a perfectly competitive market and equals the wage. MRP equals demand and MRC equals supply/wage.
Alright guys, we're going to be talking about derived demand. Derived demand can be defined as the demand for the input/resource is derived from the demand for the product. We're going to be using an example of leather shoes, with the resources being leather and the worker being the shoemaker. If the demand for the leather shoes goes up, the demand for everything else goes up as well, and vice versa. Now we're going to talk about marginal revenue product, or MRP. MRP is the additional revenue a firm yields when another unit of input of labor is added. MRP can be solved by multiplying marginal product times price, or MP&P. If you increase MP or P, so will the marginal revenue product, and if you decrease MP and P, so will the MRP will decrease as well. You can also calculate MRP by taking the change in the total revenue over the change in the number of inputs.
Now, an issue you might run into is if the marginal product and the price go in different directions. So for example, if the marginal product goes up and the price goes down, or vice versa, so if the marginal product goes down or the price goes up, you're not able to calculate MRP unless you're given specific numbers.
It's time to get up close and personal and all around. So, what do you think MRC stands for?
Multiple reading capabilities.
Interesting. And you, what do you think MRP stands for?
M always stands for marginal. Marginal robot production.
So we just talked about the marginal revenue product, and now we're going to talk about the marginal resource cost, otherwise known as MRC. So the marginal resource cost is the additional cost incurred from an additional unit of input. In most cases, this would be a worker. So MRC is usually the wage in a perfectly competitive market, since this is the cost of hiring one more worker. MRC can be calculated by finding the change in the total resource cost, otherwise known as the complete change in wage, and over the change in resource quantity, otherwise known as the number of workers you've hired.
The three shifters of demand. One is the change in demand for the product. Number two is change in productivity or new technology. The third is price of resources, complementary and substitution effects. So, an increase in demand for a product, let's say cereal, there ultimately increases the price. Therefore, the marginal revenue product of the resource used to make the cereal, aka the workers, is ultimately increased. so it shifts the demand curve to the right. New technology, let's say a robot, it's more productive than a human. So the firm has an incentive to make more product, thus the demand for the robots would increase.
So finally, we have the price of resources. For the first example is complementary goods. So think of it in terms of a human and the machine that they operate. So even though we've drawn milk and cookies, that's more of a product market type of an example. So think of what I said, a human and the machine they operate. Now, a substitution would be a product that you're able to replace with. So if a human and a robot are able to perform the same task, these would be considered substitution resources. And so if the price of one resource is lower compared to a substitution or higher, the demand will change accordingly. Alright, so we just talked about the three shifters of demand in the factor market, so now it's time to talk about the three shifters of supply. The first one is the number of workers. So for example, if there was something like a great immigration and the number of workers increased, the supply would go up since there's more workers available to work. The second one is government regulation. The most common example of this is licensing. It takes a lot of schooling and professional training that's required by the government in order to be a doctor. And so because of this, the supply is much lower than being in a profession where you're not required to have a license. So the last way that shifts supply is personal values regarding leisure. Someone's much less likely to work if they're working at times and at a price point where they'd much rather use their free time rather than working. So if a company is offering $8 an hour for 15 hours a day, someone will choose their free time over that, and therefore supply will go down.
Another question for you. What do you think a monopsony is?
Says, I don't know.
Do you think it relates to a monopoly in any way? Good, good. Okay.
Alright, so for next we're going to talk about a monopsony, which is what occurs in imperfect competition in the factor market. So an example of this would be in a small town, there's one big company, and they're the ones that are pretty much hiring a majority of the workers in that town. So some characteristics of a monopsony is where one firm is hiring the workers, like we said, and the firm is large enough to be able to manipulate the market. The workers are relatively immobile, which means they can't just pick up their bags and leave one day, and the firm is the wage maker, which means they're able to set their prices. Now, if you look at the graph, the demand and the MRP are pretty typical of the factor market, where the company is less willing to hire workers at a higher wage and more willing to hire more workers at a lower wage. But the thing that's unique about this is how MRC and supply split up. It's kind of the opposite of a monopoly in the product market. This happens because to hire additional workers in a monopsony, the firm must increase the wage for all workers. So the supply stays relatively consistent, but the more you hire, the greater your MRC is because you have to pay a higher wage. So in this graph, the MRC increases much more quickly than compared to the supply.
Decisions. It's time to make some hiring decisions. So typically in the factor market, they hire equilibrium in the industry. Individual firms hire when MRP equals MRC, because this is when the added benefit of hiring a worker is equal to that worker's cost. Included in these decisions is the least cost rule. Use this when you're comparing two different inputs of labor. The formula is the marginal utility of one product over its price equal to the marginal utility of another product over its price. So in this example, we'll be using robots and humans. The price of a robot is 10 and the price of a human is 5. You can see their marginal products on the screen. Now, if you had $25, how many of each would you hire? If you answered 2 robots and 1 human, you're correct.
So if you weren't sure how we got that answer, it's pretty simple. So here's the formula that you would use. The marginal utility over the price of a product compared to the marginal utility over the price of another product. So if you're comparing robots and humans, if you first look at the first robot you would hire, it gives you a marginal utility of 100 and the price is 10. That gives you an overall ratio of 10. Now if you look at the human, the first human you would hire, gives you a marginal product of 50 over a price of 5. Now for this first one, since they're equal, it wouldn't necessarily matter which one you'd hire, but you would hire both of those first, and that would give you $15 spent and $10 left over. Now you would look at the next quantity. A robot is still $10 to hire, but its marginal product is now 90, so that gives you a ratio of 9. Now with the human, its marginal product is 40, and its price is still 5, which gives you a ratio of 8. So, because the robot has a higher ratio of 9 to 8, you would then spend your remaining $10 on a robot.
Quick, draw the Lorenz curve with this piece of paper and this marker.
What it is.
Good luck.
That's all I know. I don't know.
Not bad, not bad.
Alright, so now we're going to talk about market distribution of income. The best way to look at this is the Lorenz curve. So, in the Lorenz curve, as you're about to see right here, a completely straight line at a normal slope of 1 is considered perfectly equal. So, this is your base graph, but unfortunately this doesn't really happen in real life. So, as you can see, B, with the line that kind of dips inward like a banana, is what more realistically happens. The Gini ratio is what is used to calculate that area, which is A over A plus B. When Gini ratio is equal to 0, you have a completely equal distribution of income, but if the Gini ratio is close to 1, it shows income inequality.